Okay, so before you begin your work for today, we're going to go over some crosses. Here's my little makeshift board here. So you need to have a piece of paper out. I can't see my little... Y'all get a piece of paper out and I will figure out this text box situation. So remember, homozygous means the same. So we're going to do a homozygous cross first. And you need to draw a little bitty a box. Draw some Punnett squares. You should have done this in, I think, 7th grade. So this should be, if you listen in class and remember, it should be a review. So a homo cross. All right, so let's do, we always talk about eye color. Even though eye color is so much more complex than just one gene, we're still going to do eye color, okay? So let's do a brown-eyed dad that's homozygous. That means he's brown-eyed, which is his phenotype, and his genotype is big B, big B, okay? Does not matter where you put the mom or the dad. Then let's do the mom is going to have blue eyes, so she's going to be homozygous recessive. Her phenotype is blue eyes, and her genotype is little b, okay? So if I was with you right now, I would say things like, Talia, tell me what goes in the top left-hand box, or whoever's in my class. But I'm not there, so I'm just going to give you some wait time. If you know how to do this, please go ahead and fill it out on your paper. If not, you can wait on me. So all you do is you take the top allele and the allele that's directly across from it and put it in the box, okay? So these are representatives of alleles. So you always write the dominant one first. Big B come from the top. Little b comes from the side. Big B, little b. Okay? What's on the top? Big B from dad. Little b from mom. What's on the top? Big B. What's on the side? Little b. What's on the top? Big B. What's on the side? Little b. So don't think of each box as a child. Think of it as the chance you're going to get those genes. Okay, so if these two were crossed one time, what are the chances that they would have, a heterozygous, brown-eyed heterozygous child? 100%. Every time, every cross of every gene, no matter how you do it for these eye colors, for these two people, they're all the phenotype, I can ask a million questions from this. I can say, what's the phenotype of this child? What are the chances this child is going to have brown eyes? 100%. There's no other way. There's a 100% chance. I'm doing this with a computer or laptop mouse. It's hard. 100% chance they're going to have brown eyes. Gosh, I should have wrote a text box. And there's also a 100% chance that they're going to be heterozygous. I'm just going to write hetero to save us some time and me some embarrassment because this is terrible. Okay. Or you could put, you might want to write 4 out of 4, BB. Big B, little b. 100% chance. If I cross a true bred brown-eyed person with a true bred blue-eyed person, okay? This is just like he did with the flowers, the purple flower and the white flower. All the F1 generation was the same color, right? They were all purple, or they're all going to be brown-eyed. So what happens when I cross let's do a heterozygous hetero cross. So again, this is what happened. He crossed the F1 generation, Mendel did, okay? So let's take this guy and cross it with this guy, okay? I hope y'all can see blue, or I hope you can see green. All right, so I'm going to take this guy and put him on top. Big B, little b. You just put them directly over the squares. And I'm going to take this, I should say gal, and put her on the side. Big B, little b. This on the left would be the parental cross, and this on the right, for Mendel's purposes, was the F1 generation cross. So it's a heterozygous cross. Where do I get those names from? I get them from the big B and the little b and the parents being different, okay? Hetero means different. All right, so I would, if I was in class, I would ask, someone what would be put in the top left-hand box first. So if you know, please go ahead and fill it out. I really hope you're not, just staring at your phone or putting makeup on and just writing down what I write down and not listening. So what's on directly above this little box? Big B. What's directly across from it? Big B. That's definitely different from over here, right? So what's directly across from this, above this one is little b. Directly across from it is big B. I always put the dominant first. You just put what's on top and on the side. Big B, little b. Over here, what's on top, what's on the side? Little b, little b. So this one is the F1 generation cross, or just in general, somebody that looks like they have brown eyes, but they're carrying a blue-eye trait. Have brown eyes, carrying a blue-eye trait, okay? So what are the chances that a hetero cross is going to have a brown-eyed child? Well, is this one brown-eyed? Check. Is this one brown-eyed? Yes. Even though it's heterozygous, its phenotype is still brown. Yes. Check. Is this chance, if the little kid gets these genes, is it going to be brown-eyed? Yes. What about this one? No. Okay. There would be a 75% chance that your child would have brown eyes. Or just like we saw in the F1 generation with the flowers, it's a 3-to-1 ratio, okay? We're talking about phenotype here. 3-to-1. They're going to be brown to blue. I could also ask you, what is the chance between a hetero cross, what's the chance that the child will be heterozygous as well? Is this heterozygous? No. Is this one heterozygous? Yes. Means different. Is this one heterozygous? Yes. And is this heterozygous? No. That means there's a 50% chance that the child from a hetero cross would be heterozygous as well. I hope that makes sense. What's the chance that the child will be blue eyes? There's a 25% chance that this child would have blue eyes, right? Because there's only one of the 4 options from crossing mom and dad's genes. So we're going to do one more cross, and then I'm going to let you get started on your classwork. Let me draw my little Punnett square here. You need to draw yours as well. I could actually do 2, but I'm not going to do the recessive because that's kind of self-explanatory. All right, so let's do hetero-homo cross. So heterozygous crossed with a homozygous, okay? Heterozygous means what? Different. I could use any letter I wanted to, whatever I'm talking about, to help me remember what I'm talking about, okay? Heterozygous means different, but right now we're still talking about eye color. Homo means the same. So I have to actually go back up here and write homozygous dominant or homozygous recessive because they're both going to be different. Let's do recessive. Write that in your notes. Homozygous recessive means little b, or, two recessive genes. So this is actually Kate's mom and dad. This is Robert. This is how I know Robert's heterozygous for his eye color because of Kate, because Kate has blue eyes. And the only way Kate has blue eyes if her dad also carried this little b, okay? All right, so just like before, do your Punnett square. I'm going to be quiet this time, and I want you to do it on your own. Okay, so what were the chances that Kate was going to have blue eyes? %, right? Is this crossing of the genes? Is this blue eyes? No. Is this blue eyes? Yes. No. Yes. Okay. So this is a 2 to 2 ratio. You're going to get 2 brown eyes, 2 blue eyes, okay? There's a 50% chance that Kate was going to have blue eyes, and she does. So I know that Kate, because she has a recessive gene showing in her phenotype, I know Kate is carrying a blue-eye trait for her set of alleles. She has 2 recessive traits. And anybody in here with blue eyes is the same way. So eyes are kind of difficult. So green eyes are kind of the same as blue. We're going to count them. They're recessive to brown anyway. So Hattie and Scarlett are heterozygous like their daddy. They have brown eyes, but I know they're carrying a recessive gene from me because I do not have brown eyes. I could ask you a ton of questions from all of this. I can say, from a hetero-homo recessive cross, what are the chances the child would have blue eyes? And your answer should be 50%. I could go up here and say, from a homozygous cross, what are the chances that your child would have blue eyes? And the answer would be 0. Okay. You really need to know this. You have an assignment on Schoology now that you can do on Cami. If you want to print it off, you can. I might be nice and ask Miss Willis to print you all off one before this even started. I don't know. But anyways, this is all of our crosses for chapter 11 that we're going to go over.